Hello guys, welcome to NameTech channel. My name is Nehemiah and I'm very much happy to have you on board. This is lesson 3 on Scipy and we are going to talk about optimizers. But then before we get started, please take a minute, subscribe, like and share the video to your friends. And to the returning subscribers, thank you very much for your continuous support. So guys, basically optimizers are a set of procedures defined in Scipy that either finds the minimum value of a function or at the root of an equation. Let's begin by optimizing functions. So essentially all of the algorithms in machine learning are nothing more than a complex equation that needs to be minimized with the help of a given data. About the roots of an equation, basically NumPy is capable of finding roots for polynomials and linear equations, but it cannot find the roots of an unlinear equation, like for example x plus cos x. Now for that you can use the Scipy optimize.root function, and basically this function takes two required arguments. The first one is fun, which is a function representing an equation, and then xor, which is an initial guess for the root. Now basically the function returns an object with the information regarding the solution, and then the actual solution is given under the attribute x of the returned object. Guys, let me show you an example how to find the root of the equation, perhaps x plus cos x. So what we do before anything, you must import the modules. Now let me say from Scipy optimize like should be optimize import should be import root. Also we are going to import another module. Then from math import cos, the cosine. Then here let's define a function here. Let me say def, and then let me give it equation eqn, and then let me say for example, let me give it x, and then guys, remember always to close with the colon, and then here let me say return x plus cos x like that. And then here let me say in the new line of code, first of all, remove the indentation there, and then let's say my root. You can give it any variable, my root. Then let me assign it to root into equation this function eqn, then another one 0. Then to the print function, let me say print what? Print my root. Print my root, and then dot x. Then what I do, guys, let me run this. So guys, basically you can see it has returned this value, and remember this returned object has much more information about the solution. So guys, basically if you want to print all the information about the solution, not just x, which is the root, basically you can just type in print, then root, and then you remove this x here. Like let me remove x. Then what I do, guys, let me run, and then guys, basically this is how you can do it. This is how you can print all the information about the solution. You can see you have the message, the solution converged, success, through, then the other stuffs here. So guys, basically this is how you can print all information about the solution. Now guys, let's talk about the minimizing a function. So guys, basically a function in this context represent a curve, and curves have high points and low points. High points are called maxima, and low points are called minima. Now the highest point in the whole curve is called the global maximum, whereas the rest of them are called the local maximum. The lowest point in a whole curve is called the global minima, whereas the rest of them are called the local minima. And then guys, let's now talk about how to find the minima guys, basically you can use a scipy.optimize.minimize function to minimize the function, and the minimize function takes the following argument. Fun, as I told you earlier, is a function representing an equation. Then XOR is the initial guess for the root, and then the method is the name, basically is the name of the method to use, like the legal values like a CG, BFG, Newton, CG, and so forth. And then the other one is callback, and basically a function called after each iteration of the optimization. Then another one is option, and basically this one is additionally defining the extra parameter params. So guys, let me show you an example how to minimize the function with perhaps, let me show you guys this example for you to understand what I'm talking about. So first of all, you're going to import the modules. So from Scipy, optimize import minimize should be minimize, right? And then here let's define a function. Let me say diff, and then let me give it again equation eqn, and then here let me say let me give it x, and then close with the colon, and then what I do here, let me say return perhaps x times x, and then let me say 2 plus what, 2 plus x, and then plus perhaps any value like 2 again, and then here let's say my mean, then let me assign it to minimize, and then here let me pass the equation eqn, then 0, and then a method, and remember guys, I told you that this method is the name of the method to use. And then here let me give it what, BFGS, like that. And then to the print function, let me say print my mean, and then guys, let me run the codes, and then guys, basically this is how you can do it. This is how you can minimize a function. And then guys, basically you can see that we have this information about the function. So guys, basically this is all about optimizers, and I think you've gained something. Please consider subscribing, like, and share the video to your friends. Until next time, this is Nehemiah. Goodbye.